Good morning, dear students. So, after going through the theory part, one point is left in theory part, that is second derivative test. I will be giving in between. Okay, don't worry. So, let us start the exercise. With the previous concepts of the theory, we can try this exercise. Okay, and in between, I will be also giving you instructions regarding the second derivative test. Just keep in mind. Exercise 6.5. It is asked here. Find the maximum or minimum values if any of the following functions given by this without the first derivative test. Okay, without derivative test you have to find out the maximum value or the minimum value if it is there. Okay, let us see first question. F of x equal to twice x minus 1 the whole square plus 3. So dear students, just look at this portion, twice x minus 1 the whole square. It is always a positive number. Twice x minus 1 the whole square, it is always greater than 0. So it will be, that means it is a positive number, it will be always greater than 0. So or equal to 0 it can be. So that means the minimum value of this twice x minus 1 is what? Equal to 0. That means this function will have only minimum value, it cannot have maximum value. Why? Because this is always positive. Twice x minus 1 the whole square will be always positive. So it can be equal to 0 only when twice x minus 1 will be equal to 0. That means its minimum value is what? This expression's value, if it is 0, then the whole function's minimum value will get. So the minimum value will be minimum value of f of x depends on twice x minus 1 the whole square. That is, if twice x minus 1 the whole square equal to 0, which is minimum, value of twice x minus 1 the whole square, no? So if it has got a minimum value, that means it is only 0. Otherwise it has got all the values greater than 0 only. So twice x minus 1 the whole square equal to 0. Then we can get here twice x minus 1 is equal to 0. That means x equal to 1 by 2. That is, this is the only point, that this is the point of minimum value. So when x will be equal to 1 by 2, then this function will have a minimum value. Therefore, the minimum value of the function, is f of 1 by 2. That is equal to 2 into 1 by 2 minus 1 the whole square plus 3. That is equal to 3, because this will be 0, 2 and 2 cancel, so it will be 0. 1 minus 1 is 0, so it is 3. So therefore the minimum value is 3 only. This is our answer. Okay, dear students, let's go to one more question. Look at question number 3, Roman number 3. Here you see there is a minus sign before this perfect square form, that is minus bracket x minus 1 the whole square plus 10. See, this time this will be all the time negative only, because before this whole thing there is a minus sign. So it is a negative thing. So that means this function can have only maximum value. What is the maximum value of this x minus 1 can be? It can be only 0. When this will be 0, means x minus 1 represents 0, then this will be the maximum value of this x minus 1 the whole square. Otherwise all values will be less than 0 only. Got the idea? So then the value of the function depending on this part now, whether it can have maximum value or not. Otherwise it will have all the time means what called less than means a negative number only for this x minus 1 the whole square. It will always represent, because there is a minus sign before it, so this whole part represents negative number. Got the idea? So that means we can think about only the maximum value, because its maximum value of x minus 1 whole square is 0. Since here minus x minus 1 the whole square is always negative, so the function can have a maximum value only when x minus 1 the whole square is equal to 0. Means if this part is 0, then this will be the maximum value for this whole thing. Otherwise all the values will come below 0 only. So x minus 1 equal to 0. That means x minus 1 is equal to plus minus 0. Then it will give us x equal to 1 only, because 1 plus minus 0 or no, it is just 1. So that means 1 is the only point of maximum value. So x equal to 1, that is x equal to 1 is the point of maximum value. Maximum value. Therefore, the maximum value of the function is maximum value of the function is f of 1. So that will be equal to, since this will be 0, 1 minus 1 the whole square plus 10. That means it is equal to 10. This is the answer. 10 is the maximum value of the function. Look at, dear students, look at question number 2, Roman number 1. Find the maximum and minimum values. Again, you see, f of x equal to mode of x plus 2 minus 1. Dear students, as you see, mode of x plus 2, then modulus of any number is always a positive. Modulus of any expression is always positive, means greater than 0. Then it can have minimum value only. So because all the time it will be greater than 0, or it can be equal to minimum 0 only. So the minimum value of x plus 2 is 0. So that means this function can have minimum value only, for which x plus 2, because of which this x plus 2 will be equal to 0. So we will take that way. So we will write here, the function can have, the function has a minimum value because of x plus 2, because mode of x plus 2 is either greater than or equal to 0. That means it can have minimum value 0. That is, x plus 2 can be equal to 0, for which f of x has minimum value. Therefore, x plus 2 is equal to 0, and from here what we get? X equal to minus 2. Got the idea? So x is equal to minus 2. Therefore, what you can say? Minimum value of f of x is f of minus 2. That is equal to minus 2 plus 2 minus 1. That is equal to minus 1. So this is the minimum value. Okay, dear students? This is the whole answer. So today you solve question number 1, that is question number 1 and question number 2. Please solve this. This is your homework. We will discuss the remaining in our next classes. Thank you and have a nice day.